This video is for section 5-6, complex fractions. A complex fraction is a fraction whose numerator or denominator, or both of them, contains one or more fractions, or contains a power with a negative exponent. A complex fraction is a fraction that has fractions within it. There are two methods of simplifying complex fractions. We'll practice both of them. First method, multiply the numerator and denominator by the least common denominator of all fractions. Method number two, write the fraction as a quotient using this kind of division symbol. Here's an example problem, and we'll solve it with both methods. The first thing to do is to rewrite it and take care of that negative exponent. That problem is equivalent to x minus 9 over x, all over 1 plus x over 3. X to the negative 1 power is the same thing as having an x in the denominator of a fraction. Now let's use method number 1, where we multiply the numerator and denominator by the LCD. We need to figure out what the least common denominator is. From this fraction, the denominator has an x in it. Later on in this fraction, the denominator has a 3 in it. Putting those two together, the least common denominator is 3x. Multiply the top by 3x and multiply the bottom by 3x. Apply the distributive property to figure out what you get. 3x times x is 3x squared. 3x times minus 9 over x makes negative 27. This x and this x cancel away because this one is in the denominator of a fraction. Now let's work in the bottom. 3x times 1 is 3x. 3x times x over 3 makes x squared. This 3 and this 3 cancel away because this 3 is in the denominator of a fraction. Now let's simplify this. First by factoring. In the top we can factor a 3, leaving x squared minus 9. In the bottom we can factor an x, leaving 3 plus x. The x squared minus 9 is a difference of squares. It factors farther as x plus 3 times x minus 3. And in the bottom, there's still x times the 3 plus x. X plus 3 is the same thing as 3 plus x, so these factors cancel away. The final result is 3 times x minus 3 over x. Let's do the same problem, but with method number 2. We're going to rewrite that bar as that kind of division symbol. And let's fix that negative exponent at the same time. So x minus 9 over x divided by 1 plus x over 3. This division problem is equivalent to this division problem. The only difference is that that long division bar has been written as that kind of division symbol. Next, let's actually perform this subtraction by getting common denominator so that we can subtract these two fractions. If it helps, you can put a 1 under that x. The common denominator is an x. For this first fraction, we need to multiply top and bottom by x. This makes x squared minus 9 all over the common denominator of x. Now let's work on adding these two fractions to get a single fraction. Again, you can put a 1 under here to help you keep the top separate from the bottom. This time the common denominator is a 3. So we can multiply by 3 here and by 3 here. This becomes 3 plus x all over that common denominator of 3. Next, apply the definition of division, which allows you to create an equivalent expression but with multiplication in it. X squared minus 9 over x times the reciprocal of that fraction. Now that we have multiplication, let's multiply the numerators and multiply the denominators. The x squared minus 9 will factor. And the factor x plus 3 cancels the 3 plus x, leaving 3 times x minus 3 all over x. Notice that after we had multiplied, the result was identical to the result we had here in method 1. Let's try one more example, again using both methods. So method number 1 is where you multiply by the least common denominator of all fractions. You have to figure out what that denominator is. Looking in the top, it looks like there has to be an m in the least common denominator, but looking in the bottom, we notice that one time there's an m squared. So the least common denominator is m squared. Multiply the entire numerator by m squared and multiply the entire denominator by m squared. M squared times m is m cubed. M squared times minus 1 over m is minus m. M squared times 1 is m squared. M squared times 4 over m is plus 4m. And m squared times minus 5 over m squared is minus 5. Now factor. This makes m times m squared minus 1. The trinomial in the bottom will factor as m plus 5 times m minus 1. The m squared minus 1 is a difference of squares, and it factors as m plus 1 times m minus 1. Then cancel the m minus 1 factors. We can see the final result is m times m plus 1 over m plus 5. Let's do the same problem again, but this time with method number 2, where you rewrite using that kind of division symbol. So we have the m minus 1 over m, and we want to divide that by the 1 plus 4 over m minus 5 over m squared. We're rewriting the original problem instead of using this long division bar, using this kind of division symbol. Next step, actually perform this subtraction to get this as a single fraction. You can put a 1 under there to help you see the denominators. The least common denominator for these two fractions is an m. So this first fraction needs to be multiplied by m, top and bottom. This becomes m squared minus 1 all over the common denominator of m. Looking in these parentheses, the least common denominator is m squared. So for the first fraction, we have to multiply top and bottom by m squared. But for this fraction, we only need to multiply top and bottom by m. We get m squared plus 4m minus 5 all over our common denominator of m squared. Remember, at any time, you can check that you're transforming correctly by dividing this back out in your head and making sure you get what we had in the black ink. M squared over m squared is the 1. 4m over m squared is the 4 over m. Now apply the definition of division to rewrite as a multiplication problem. Change to times and take the reciprocal of that second fraction. Now multiply the numerators and multiply the denominators. m squared times m squared minus 1 over m times the m squared plus 4m minus 5. The m squared minus 1 factors as m plus 1 times m minus 1. In the denominator, we have the m, and then our trinomial factors as m plus 5 times m minus 1. The m in the denominator cancels one of these, leaving one m left over. The m minus 1s cancel away. What's left over is m times m plus 1 in the top, and in the bottom, m plus 5. Comparing the two methods, it seems like method number 1 was the faster technique. Let's summarize the lesson. We discussed how to simplify complex fractions. There are two ways to do that, and it sort of seems like the first method is best. Multiply numerator and denominator by the LCD. Then use factoring and cancel like factors from the top and the bottom.